हेलो। तो आज हम डिस्कस कर रहे हैं परमुटेशन जॉर सम, जो कि एक लंच टाइम जनवरी लंच टाइम का डिवीजन 2 का थर्ड क्वेश्चन है। परमुटेशन जॉर सम। ठीक है, तो इसमें हमें दे रखा है कि फॉर अ परमुटेशन p ऑफ इंटीजर्स फ्रॉम 1 to n, लेट्स डिफाइन इट्स वैल्यू। ओके, सो हमें क्या करना है कि एक परमुटेशन, हमें एक ऐसा परमुटेशन लेना है जिसका ये जोड़ करने पे, जैसे 1 से जोड़ किया फर्स्ट एलिमेंट को, 2 से जोड़ किया सेकंड एलिमेंट को, ऐसे किया। उसके बाद हमें इसकी वैल्यू को मैक्सिमाइज करना है। सो वी हैव टू मैक्सिमाइज द मैक्सिमम पॉसिबल वैल्यू ऑफ द परमुटेशन ऑफ इंटीजर्स फ्रॉम 1 to n। सो ठीक है, और n भी थोड़ा बड़ा है तो log n में हमें करना पड़ेगा। देखते हैं इस क्वेश्चन को। ठीक है, तो इस क्वेश्चन में क्या है, ओके, so let's erase this. Okay, so let's understand with an example. If I have given 15 as n, what we can do here? So I write all the numbers from 1 to n in binary representation, then try to observe the pattern. So for 15, this is 1 1 1 1. 14, it's 1 1 1 0. 13, it's 1 1 uh, 0. Yeah, no, it's still okay. So 13, then 12, then 11, 1 0 1 1. It's 11, 3 8 3, yeah. So after that 11 10 1 0 1 0. 10 after that 9. So 1 0 0 1. Then 8. So 1 0 0 0. 7 7 1. No, it's 1 1 1. Yeah, similarly. So how to maximize? Oh, I have to maximize every term, so we have to maximize every term. I don't have to worry about the other term because this is plus, so I have to maximize every this term. Then how to maximize this? So let's see this, how to maximize this, how we can maximize this. So if we join with 0 0 0 1. So yeah, this is 1, this is 1. If we join with this, then this becomes 15. because 1 jar 0 1 and all are ones, so this becomes 1 1 1 1, so this becomes 15. When we jar this element with 2 with 2, which is 0 0 1 0, then this also becomes 15. Then this also becomes 15. Similarly, for this element, if we take 3, it becomes 15. For this element, when we take 4, it becomes 15. For this element, when we take 5, which is, it becomes 15. For this element, when we choose 6, this becomes 15. So it's 15, 14, 13, 8. So for this 8, if we choose 7, this becomes 15. For this 7, if we choose 8, then this becomes 15. So similarly, if we let's say for 6, now after 7, 6, to 6, for 6 we choose 15. For 5 we choose uh, this element, which is 10. For 4 we choose 11. For 3 we choose 12. For 2 we choose 13, and for 1 we choose 14. And for 15 we choose 15, because we are maximizing all these elements till 1, and we this is left, so I don't have to worry about this, so we can for this we can use 15, and this becomes 0, because 15 is left for till 14 we use, so 1 to 14 we use all the elements, so only 15 is left, so for last element we use 15. So so the answer for 15 becomes 15 into 15 into 14, because till 1 till 1 all are all are 15, after we jar with the permutation. So total elements are 14, because the last element is 15, which is 0. So 15 into total elements are 14 is my answer. So let's check, oh, minus 15 is, so this is 210. 210 is our answer, which is the maximum possible value, So yeah, similarly, if we understand, if we have let's see, let erase this. This is 15, this is 14, so let's check for eraser. Okay, yeah. So this is 13, this is 12, this is 11, this is 10, 9, and 9, and this is 8. Again, for maximizing 13 we have to choose 1 0, which is 2. Which is 2, so then it becomes 15. So for maximizing 13 we have to choose 1 0, which is 2, so it becomes 15. Similarly for 12 we have to choose 3. For 3, sorry, 3. For 11 we have to choose 4. For 10 we have to choose 5. For 9 we have to choose 6. For 8 we have to choose 7. But this goes till 2. This goes till 2, and for 2 we have to choose 13, and it becomes 15. It becomes 15. Sorry, it becomes 15. But one is left. Till 2 we calculated, and the total 15s are 13 minus 2 plus 1. 13 minus 2 plus 1. Total 15s are this much. So this is 11 plus 1, which is 12. We have 12 15s only. We have 12 15s because you can count 2 to 13. Total we have 12 15s. So we multiplied with 15, and 2 is our the lowest element. Till 2 we calculated all these 14 to 2 we calculated all the possible permutations and its sum. Then I have left 1. So for 1 what we can do? For 1 we have to choose 1. Jor, when this becomes 0, then we have to add 0 in this, and this becomes 12 into 15. You can multiply this. So this is my logic. Let's see my code. Yeah, so here I have taken n, and then answer is 0 initially, and then till n greater than 0, we have to calculate the lowest value which is required n. So I created a function required n. So I'm discussing. So low is required n. So this is I am calculating that for 13 what I have to choose, that this job becomes maximum. So for 13 I have to choose 1 and 0, which is 2, so I have to choose 2 for 13. For 13, that the job becomes maximum. So in a required function I'm calculating when the n is 0. So let's for n is 13, and that's 1101. So when we encounter 0, so n will be equal to 0, then we are adding in the answer as a 2 into power of z. So this is 2, so we are adding in answer 2, and after that there is no other 0, so we are returning 2 here. So for 13 we are returning 2 is my lowest point, till we can jar all the elements. So required is the lowest point, and after that if low is not equal to 0, Then what you have to do, you have to answer plus uh, log or n. So this is low is 2, low, low is 2, and 13 is n, so lows or n is 15. So this becomes 15. So after that, how many 15s I have? So I have n minus low plus 1 15s, n minus low plus 1 15s, and we are updating the n, so n becomes low minus 1. And if low equal to 0, that is for 15, uh, which I discussed earlier. So for 15, if we have 15, that is 1 1 1 1. Then for this, you know our required function is 0. Our required is 0. So if we have required is 0, so for 14 we can calculate all the permutations and sum, and we added 0 to the answer. So answer plus n into n minus 1 elements. So I am calculating for n minus 1 elements, and we are updating the value n to the 0, and after that we are printing the answer. So yeah, that's it. This is my logic and this is my solution. Thank you.